Okay, everybody, we're taking a look at lesson 5-4, and our target today is that we can solve ratio problems by using tables and graphs to show equivalent ratios. So it's really building off of the work that we did at the end of topic 4 when we were working with our equations and looking how we could build an equation, a table, and a graph. So very similar. So let's take a look at this problem here. It's on page 285 of your book. For every 4 adults at the beach one afternoon, there were 3 children. How many children were at the beach? So we know that there were, for every 4 adults, there were 3 children. And so now they want us to, how many children were at the beach if there were 8, 12, 16, and 20? So boy, this is so nice and neat. They gave us this table, and look at that. It's exactly what we need. So if you notice, we are just doubling these. So what are we going to do with the children? Because you've heard this umpteen thousand times. If we do it to the top, we're going to do it to the bottom. So 3 times 2 is 6. What do we do here? 4 times what gets us to 12? Yep, times 3. So you're going to notice that we have a little projection here. So 3 times 3 is 9. This next one, 4 times what is 16. So can you make a guess what the last one is? Yep, times 5. So 3 times 4 is 12. And 3 times 5 is 15. So that, I think you guys could just rock out of the park there. But now what are we going to do when we go to graph it? So if we have our dependent variable and our number of children. So for every 4 adults, there are 3 kids. So let's take these as our coordinate points, just like we did before. So number of adults is 4, and the number of children is 3. So we're going to put a little point right there. If I have 8 adults, then I have 6 children. If I have 12 adults, I have 9 children. So I'm going to go right between 8 and 10. If I have 16 adults, I'm going to go to 12. Do you see this nice linear line here? And if I have 20 adults, we are at 15 children. So if this is nice and neat, and I have my ruler to help me on this, I can connect these all together, and it can help me decide some information there. So I think you know how the graph can show the ratio, but I'm going to pause, and I want you to do this focus on math practices. So in the Ed puzzle, there were 25 children and 15 adults at the beach. Emery said that there were 5 children for every 3 adults. Is he correct? And you need to explain it to me. So we're going to pause there. Okay, everybody, let's take a look at example number 1. It's on page 286. And so for this one, we're looking at some party store decorations with balloons that have 3 balloons for $2. So that's a 3-to-2 ratio. And we're going to make this table to show how much Ellen would spend if she bought 3, 6, 9, or 12 balloons, and we're going to plot those pairs, okay? So how can you make a table of equivalent of ratios or a graph to find the cost of the number of balloons? So they were kind of nice, and they filled these in for us, and they've got 3, 6, 9, 12, and we like this. It goes 2, 4, 6, 8. We know that we take these in, and we can plot it just like we did on the other example. And so if Ellen could buy 3 balloons, it's going to be $2. 6 balloons will be $4. 9 balloons will be $6, and 12 balloons will be $8. So what are the coordinate points that represent the number of balloons that you could buy for $6? So here's our $6. And you're going to tell me what would the coordinate points be. So if I go over, now remember, which one do we put first? X or Y? Yep, we're going to do the X first and then the Y. So for this one, it looks like it will be 9, 6. And does that match our ratio table up here? It absolutely does. Okay, so we're going to pause, and I want you to tell me on Edpuzzle, how can you use the graph to find the cost of the 15 balloons? This is why I love how all these things come together. If I wanted 15 balloons, I could come over here. I'm going to go right in between 14 and 16. I'm going to go up to where it meets the line, and look at that. It is $10. So 15 balloons would cost $10. Love that. All right, so now we're going to look at, sorry about that, example number 2. Jack is making juice. He has 25 celery sticks. He can use all 25 celery sticks, but how many apples will he need to make the juice? So it looks like our ratio is a 5-to-2 ratio. He goes down, he's adding 5 or multiplying it. You could do that as well. And it looks like they doubled here too. So this is kind of interesting because it's going to go up 2 over 2, up 2 over 2, up 2 over 2. Someday in algebra, you're going to look at what we call slope, and this is a direct correlation of that. So someday when you hear slope, or if you want to Google it, you're going to know what that means. So for Jack to do to use all 25 of the celery sticks for his juice recipe, he's going to need 10 apples. And so you can either use the table to solve this problem, or you can use the graph and go over to the 25, and it comes up to 10. And so I love when all of these things come together. Okay, so for our last example, we're going to use a couple of formulas for circles and using pi. So the diameter of a circle is 2r, so 2 radiuses. And circumference is 2 pi r, so we would take that and we would go all around. So the measurements of different circular objects are given in a ratio table. What do you notice about the graph of the pairs of values given in the ratio table? So I'm going to pause here, and I want you to look at these relationships and see what you, and maybe it's with some of the information I've given you, what do you notice? Okay, we're back, and you might notice that it's about pi that we're adding in there, and you might have seen that also in the 2 formulas there. So you'll notice that the value of the table and the value of the graph, that everything is the same. So on this last part of our Edpuzzle video, can you draw an object with a diameter of 10 and a circumference of 50? I want you to tell me yes or no and why.